everyone to our presentation on antibacterial resistance. I am Jesse Jen, and these are my teammates Daniel Zhang and Irene Wu. We are all 8th graders from Hopkins Junior High. We are participating in the challenge, Simmons We Can Change the World. Before we begin, I would like to thank our mentor Quentin for helping us along the way. Without his help, we would have never gotten this far. I would first like to ask some questions. How many of you guys wash your hands daily? Okay? How many of you that wash your hands use antibacterial hand soap, and what are some reasons why? Oh, yes? Why do you use antibacterial hand soap?
Because all the antibiotics.
Oh, well, that's a very good answer, because that was an important factor in our research, which Irene will later explain. For the past 4 months, we have been conducting research with Quentin as our mentor about the abuse of antibiotics and how it affects our community. Just weeks ago on Yahoo, there was an article on 2 superbacteria, MRSA and CRKP. This is only showing how widespread superbacteria are now these days. The only known cure for these may lead to lung or kidney failures. Now I'll go on to talk about what are antibiotics. Anti means against, and bio means life. This means against life, but antibiotics are mainly targeted on bacteria. Antibiotics are used against infections caused by viruses, such as the common cold. Most people don't know this, so when they get a cold, they always ask their doctors for antibiotics, but it's still useless. The most widely known antibiotic is perhaps penicillin, famously made from mold. Antibiotics are meant to inhibit the growth of bacteria to later on destroy them. Before antibiotics, people have died from the most simple of injuries and infections. For example, in Europe, in the 13th century, the Black Death raged through Europe. In the end, an estimated 60% of the population has died due to the bacterial Y. pestis, while pneumonia has killed 60% of the elderly and infants of those who got infected. Bacterial meningitis killed up to 70% of the elderly and infants, and tuberculosis caused more deaths between the people 15 to 45 years old than any other contagious disease combined. I'm now going to talk about the history of antibiotics. In 1928, Sir Alexander Fleming observed that colonies of Staph aureus were inhibited by the cells of penicillin. So the first time someone has ever noticed the effects of penicillin and have reported about it. In 1941, penicillin was used in World War II to help wounded soldiers. This was the first major use of antibiotics in the world and has saved countless American lives and prevented numerous bacterial infections. Present-day antibiotics. People more than ever are being scared of being sick and will do anything to prevent it. According to an EPA study, 40% of all bacterial prescriptions are abusing antibiotics. In 2008 alone, more than 250 million bacterial prescriptions were written. This number has only been rising in the past couple of years. In third world countries, you don't even need a prescription for antibiotics. You can just walk into the pharmacy and ask them, and they would give it to you without question. In the 1990s, farmers have began to give their animals antibiotics in hope to cure them from infections. The result was, when these animals were slaughtered and eaten, we would be eating the antibiotics that the farmers gave to their animals. What are superbacteria? 70% of all bacteria are already all slightly resistant to antibiotics. Like I mentioned before, MRSA and CRKP are already almost completely immune to even our most powerful of antibiotics, and the only known cure for these may lead to lung or kidney failures. How are we supposed to cure the most simple of bacterial infections if we can't kill the bacteria? Now, how do superbacteria form? One important way on how superbacteria form is the bacterial biofilms. A bacterial biofilm can spread the way on how to be resistant to antibiotics. The way this works is when a bacteria that is already resistant to a certain type of antibiotic lands on a biofilm, it spreads the information to all the bacteria in the biofilm, so it makes them all resistant to that certain type of antibiotic. Another way is the how quickly the bacteria reproduce and the genetic variation. Bacteria reproduce at a very fast rate, which leads them to have some mutations. Some mutations may lead to the bacterial resistance. And when these bacteria breed again, they will become stronger and will be more resistant to those type of antibiotics. This is basically Darwin's theory of evolution. The strong ones will thrive and the weak ones will die. The last reason on how superbacteria form is the Efflux pump. Active Efflux is a mechanism which all bacteria have, which pumps out toxic stuff, such as antibiotics, out into the open. So this means that when a bacteria gets an antibiotic, it just pumps it out. Now my teammate Daniel would like to come and talk to us on how does this affect us.
Thank you, Jesse. As Jesse said before, people die from the most simple of diseases and bacterial infections. If we continue to abuse the antibiotics at the rate we are right now, one day in the near future, we can imagine a world where bacteria can kill us indiscriminately and we will have no defense. If we imagine a world where Black Death, or we will have another Black Death that can kill up to 60% of our population. However, we are not only focused on antibiotics, we are focused on the antibacterial triclosan into consumer products. This is only speeding up the process of antibacterial resistance. In 2011, more than 700 consumer products contain the antibacterial triclosan. However, there are also in teddy bears, toothpaste, paint, daily items, and also hand soap. Triclosan has also valid uses. Triclosan was first used in 1970, where it was used in hospital settings. It was used to disinfect hospital surgery rooms and equipment. Also, triclosan can be put in toothpaste and mouthwash to prevent and slow progression of gingivitis. According to an EPA study, EPA has also approved that triclosan can be used in 20 pesticide formulations, from credit cards to baby countertops. Although triclosan is valid, can have some valid uses, our reliance on on triclosan as an antiseptic is only increasing the rate of triclosan-resistant bacteria. Our team mission is to decrease and later eliminate the usage of antibacterial soap to protect the environment, because the byproduct triclosan degradation causes two potent carcinogens, to suggest better alternatives. Our work shows that regular soap works just as well as antibacterial soap. So there's no reason why to choose over antibacterial soap and over regular soap. In January, we did a survey. We went to our local pharmacies and groceries to look at soap. We found that 80% of these stores contain antibacterial soap, which leaves our consumers with few choices. We also did a random survey of about 100 adults. We found that 83% of the respondents' households use antibacterial soap. 70% of the people do not know the difference between antibacterial soap and regular soap. And most surprisingly, 80% of the people chose that they would not switch to antibacterial soap or regular soap, even if they knew that antibacterial soap harmed the environment. These people do not care about the cleanliness for the environment. So this is why my teammate Irene is here to tell us about our experiment and our results.
Thank you, Daniel. Our turn. We conducted two very important experiments. One to test how effective regular soap was compared to antibacterial soap on DH5 alpha soap. The other experiment tested how effective regular soap was compared to antibacterial soap on common mold and bacteria in our environment. This is how we conducted our first experiment. We had plates, and we on DH5 alpha, we cultured bacteria in 50 milliliters of LB broth. We plated them in LB nutrient plates with either 0% soap, 5%, 25%, or 50% concentration of either antibacterial or regular soap. Here is the figures for our results. This is the 0% plates, we observed a lawn of bacteria cells on these plates. We confirmed this lawn of bacteria by swabbing this with a sterile Q-tip, and then showing that this lawn of bacteria was alive by restreaming it onto a new LV plate. Even though the lawn isn't very visible in this picture, it was because that we were lacking of a camera of laboratory quality. The next figure shows that these plates incubated bacteria cells with 50% antibacterial or 50% regular cells. These plates had no live cells. These plates show results for DH5 alpha cells incubated with 25%. So you can see several moles in the 25 antibacterial cells. In the regular, we don't believe that there is a lawn of bacteria compared to the 0%, the 5% plate. These plates show results for the DH5 alpha cells incubated at 5%. They display no lawn compared to 0%. Second experiment. We sampled microorganisms by streaking from various places, such as the piano, the table, the floor, etc. We swabbed the microorganisms onto the LV nutrient plates. We added 0.25 milliliters of 50% concentration antibacterial, regular, and antiseptic wipes, which we got from the manufacturer license. These are the figures for our second experiment. Here we have the negative control, the positive control, the regular, and antibacterial, and white. We added bacteria to all these except for negative control, and we added no soap to positive control. The negative control served as our control in this result. The DH5 alpha cells were completely sensitive to soaps at concentrations as low as 5%. The effect of soaps on mold suggests that the soap's action on mold is less effective below concentrations less than 50%. Overall, regular soap works just as well as antibacterial soap does at eliminating the growth of organisms on plates. What we can do. The first step is to limit our own antibiotic use. Then we can research to educate ourselves on the problem. And we can also answer other people's questions this way. Let our voice be heard. We can write complaints to soap manufacturer companies, write essays and submit them to magazines so that we have an even larger audience. With everybody's contribution, we can prevent the development of superbacteria.